Adding and subtracting complex numbers is just like adding, subtracting any other letter. So what we're going to do is we're going to add like terms. So if I'm adding 5 and 2 because they're like terms, I'm adding, I get 7. And if I add a negative 7i to a positive 4i, I get a minus 3i. And so we can't add these together or subtract them, so our answer is just that. Same with subtraction. In subtraction, I would change every sign, everything to the right of subtraction sign to its opposite and add. So if I change the positive 3 to a negative and the negative 6i to a positive, I can then add 4 and negative 3, which is 1, and then I can add a negative 8i to a positive 6i, which gives me a minus 2i. And once again, because those are unlike terms, I cannot combine them. All right, multiplication is a little bit difficult or different. Now we're going to use our FOIL that we've used in the past. So I'm going to take the 6 times the 9, which is 54. And I'm going to take the 6 times the 2i, which is 12i. And negative 8 times 9 will be a negative 72i. And then here's where it gets tricky. A negative 8i times a 2i is using what we did before. The numbers get multiplied, so negative 8 times 2 is negative 16, but I times I is I squared. And I squared, if you remember from last time, is a negative 1. So if I combine like terms, so the 54 can be combined with anything, but these two can be added. So that would give me a minus 60i. And then this right here is a negative 1. So we have a negative 16 times a negative 1, which makes this a positive 16. Now, after I get rid of the I have a 54 and a 16 that are like terms. So we have to combine them, which gives me 70 minus 60i. And there's my answer after I think the multiplying. Okay, division is probably the most complex, and ironically for complex numbers. To do division, what we're going to do is we need to conjugate the denominator. So to do that, we're just going to take whatever the denominator is and change its sign. If it's a plus, I'm going to make it a minus, and I'm going to write that on both top and bottom of this. And now I'm going to multiply. So I'm going to multiply 2i times all of this. So 2i times 3 is 6i, and 2i times a minus 6i will be a minus 12, and once again we get I squared. Well, I squared is really a negative 1, so negative 1 times negative 12 is a positive. So I have a positive 12, and I'm going to put it in the correct order, number before letter. And so there's my numerator. Now let's do the denominator, which is just FOIL. So that's 3 times 3, which is 9. 3 times a negative 6i is a negative 18i. 6 times positive 3 would be a positive 18i. And then a positive 6 times a negative 6 is a negative 36. And the i's get squared. So if we look at this problem, the denominator, this goes to 0, which is why we changed our sign, so that cancels. And this is a negative 1, so negative 36 and negative 1, which is a positive 36. And it gets added to the 9, which makes it 45. So our denominator is 45. And so our answer ends up without a letter in the denominator, which is what we're trying to do, and we've done division. And there's our answer. So let's look at the next type of problem doing the same exact thing. I'm going to multiply by that letter. In this one, we don't have to change the sign because there's no plus or minus. By multiplying by the exact same thing, I end up, let's just do the top first. So if I do 5i times 4, I get 20i. 5i times I will give me a plus 5i squared. There's my numerator, which we'll get to in a second. And then 5 times 5 is 25, and we get I squared. The whole purpose of multiplying by that is to get rid of the i's on the denominator. So let's finish the top. This is a negative 1, and negative 1 and 5 is a minus 5 plus 20i. And then this is a negative 1 times 25 makes this a negative 25. And so we end up with our answer with no I in the denominator.